Hi, I'm Allison.
And I'm Breanna, and today we'll be talking about the biomechanics of hitting a baseball.
To start off with some history, baseball is known as an American pastime. It is played with 9 players on the team on the field at once. Batters try to hit the ball in order to run the bases. Scoring is done by reaching home plate after touching each base on the field. The team that scores the most runs in 9 innings wins. Movements include throwing, hitting, running, sliding, and pitching. For this presentation, we'll be focusing on the movement of hitting the ball.
A baseball player undergoes 4 stages of motion throughout the process of hitting the baseball. The first stage is called the stance phase, where the player balances his or her weight between their 2 feet. The second phase is called the loading phase, where the player prepares for the swing by shifting his or her weight towards the rear foot and rotating their spine backward in a cocking motion to prepare for the hit. The third phase is called the launching phase. During the launching phase, the player forwardly rotates their spine, begins to open their hips towards the pitcher, and guides the action of the bat with their hands. This is the phase where the ball comes into contact with the bat. The final phase of swing is the follow-through phase. The player's hips open completely towards the pitcher, and they fully extend their arms. Ground reaction forces and center of pressure play a key role during hitting. A ground reaction force represents the interaction of the body with the ground. Additionally, each ground reaction force is split into 3 resultant forces, including RZ, RX, and RY, in a global reference frame. To the right, we have an example of a hitter in baseball with this global reference frame. Center of pressure while standing is the point of application of the ground reaction force acting on the person. Center of mass is the point in a body or system of bodies at which the whole mass may be considered as concentrated. Now we will be going through the 4 phases of movement and how ground reaction forces, center of mass, and center of pressure relate. In the preparation phase, the player distributes their weight evenly between both feet. Therefore, we can conclude that ground reaction forces between the 2 feet are even. In the loading phase, the majority of the weight is centered towards the rear foot. The front leg of the player can possibly be lifted depending on the hitting style, which breaks all contact of the forefoot, creating an open kinetic chain. An open kinetic chain occurs when a distal segment is free and not fixed to an object. This simultaneously increases the total ground reaction force exerted by the back leg and back foot. According to a recent study, this is approximately 102% of body weight exerted onto the ground through the rear foot. By shifting the weight to the rear foot, the hitter has moved his or her center of pressure behind the center of mass. This moves the body out of an equilibrium state, where the center of pressure and center of mass are no longer aligned. This causes the body to motivate towards the direction of the center of mass. This brings us to the swing phase. In the swing phase, the forefoot initiates contact with the ground. And when this occurs, hitting becomes a closed chain process. A closed kinetic chain occurs when a distal segment, in this case the forefoot and rear foot, is fixed in space and immovable. Total body weight is shifted forward as forefoot heel makes contact with the ground. The forefoot now holds approximately 123% of the player's body weight, and the rear foot holds about 58% of the player's body weight. The final phase is the follow-through phase. This happens when the player's front leg stiffens and the majority of their body weight is distributed through the forefoot. Ground reaction forces cause a kinetic chain throughout the player's body. The outcome of this is increased angular velocity and linear velocity.
The second concept we'll be discussing is power. Power is the amount of work performed in a given time. Power is caused by angular velocity by multiplying it by the force. Power is also defined as work over time. Therefore, the faster the velocity, the greater the power. The more angular velocity the body has, the more force will be produced, which can be translated to the bat via the kinetic chain. To apply it to baseball, the kinetic chain transfers the force from the lower body to the upper body and then to the bat. This transfers force from the body through the bat to the ball. The higher the force, the quicker the velocity and the more power. The more power that is produced, the further the ball will go. Angular velocity of the body is transferred to linear velocity of the bat, which produces a change in power output onto the ball. The force produced by muscles is translated to angular velocity, which is converted to power, which then turns into linear velocity. Linear velocity is the velocity of an object traveling in a straight line. It is the tangential component of angular velocity of a rotating mass. Linear velocity is directly proportional to the distance from the axis of rotation. Contrary to angular velocity, it is different for each point on a rotating body. Body segments combine to form linear motion on rotating bodies. Velocity is defined as distance over time and is measured in meters per second. Linear momentum is a mass in motion. Therefore, if a body of mass has linear velocity, it will have linear momentum. To apply this to baseball, the end of the bat has linear velocity while it is being swung. When the body shifts quickly, the bat is moved around the axis of the trunk, which increases angular velocity of the body and linear velocity of the bat. The further the trunk of the hitter, which is the axis of rotation, is from the end of the bat, the more linear velocity the bat will have. As the shoulders rotate, which cause angular velocity within the body, the maximum velocity is reached right before hitting the ball. After this, the arms begin to slow to prepare for the follow-through phase. Individual batters can find the optimal velocity and therefore momentum to increase accuracy and improve hitting performance. This is done by creating more angular velocity at the hips. The bat can then be flattened to create more linear velocity, which helps the batter hit the ball in the desired direction. Therefore, by increasing angular velocity and decreasing the time to swing, hitters can increase the bat's velocity.
Momentum is produced in large leg muscles and torso of the hitter and transferred to the ball via the kinetic chain. By increasing velocity of the bat, the momentum is increased and there is more power in the swing. In conclusion, ground reaction forces cause a kinetic chain within the hitter's body through all four phases of movement. The outcome is increased angular velocity in the body and increased linear velocity in the bat.
Angular velocity results in power being produced in the bat, making the ball go further. Therefore, you should swing faster, not harder. Small hitters can hit home runs just as well as stronger players, as long as they swing faster.
These next 3 slides show our references. Thank you for your time.